Today we are going to learn how to solve an inequality using addition or subtraction. There's not a lot of background information that we need because we've done all of our background information when we were doing equations. So let's jump into our first example, example 1, solve an inequality by addition. And our example says that Kate took $3 out of her purse and she still had at least $8 in it. How much did she have to begin with? At the bottom or somewhere on your paper, make yourself a little note. We are going to kind of define at least and at most. So I'll do mine over here at the right. Let me do red. So at least okay, so at least you're going to use the greater than or equal to symbol, and at least means that amount or more. So if you have at least 2 dogs, that means you have 2 dogs, but you could have 3, 4, 10, 50. So at least is greater than or equal to. Well, at most, you use the less than or equal to sign. So, and at most, that amount or less. So if you have at most 2 dogs, that means you could have 2 dogs, you could have 1 dog, or you could have 0 dogs. So just a little bit of a clarification, you might want to put that somewhere in your notes. So let's go back to our example. Kate took $3 out of her purse, and she still had at least $8 in it. How much did she have to begin with? All right, it says write an inequality to represent the amount of money in Kate's purse. So our inequality is going to look, she has M, so she started out with money. She spent or took $3 out, so that's subtraction. And then she still has at least $8 in it. So the amount in Kate's purse is still $8 or more. So there's what our inequality looks like. Then part B says solve the inequality using the algebraic process. Treat the inequality sign like an equal sign. So I'm going to do that over here. M minus 3 is greater than or equal to 8. I undo subtraction with addition. So the amount of money that Kate has is greater than or equal to $11. And then I'm going to graph that solution on a number line. Alright, so it's greater than or equal to, so it's a closed dot, and then this part to the right is going to be shaded. Alright, and then it says, what does the solution tell you? The solution tells me that before Kate spent $3, she had a minimum of $11. She could have had $11.01 or $100. So go ahead and write that down, and I will too. Okay, so there is what I wrote. Before Kate spent $3, she had a minimum of 11. And then just to kind of make sure that I understand that, I wrote it could have been $11.01, $11, or $150. We don't know. But she had at least $11. All right, so let's look at example 2. Example 2 says solve and then graph the solution. So I have x plus 4 is less than 9. And I'm going to do it over here so I have room to work. I have x plus 4 is less than 9. And I solve an equality just as if I'm solving an equation. So to undo addition, I subtract. If I subtract 4 from one side, I have to subtract 4 from the other. X is less than 5, so that is my answer. Then to graph it, that means all numbers, so X represents all numbers that are less than 5. So it's less than, it's going to be an open circle, and it's going to be all numbers less than 5, so it's going to go to the left. There's what my graph looks like. All right, then part B says choose a value in the shaded area of their number line. Okay, I'm going to choose 3, just because that's what I'm going to choose. So I choose 3. You do not have to choose 3. You can choose anything that's in the shaded area. Substitute it into the original equality. So x is no longer x. X is 3. So I have 3 plus 4. Is that less than, so question mark, less than 9. 3 plus 4 is 7. 7 is less than 9. Yes, that's true. So does this make this value make the inequality true? Yes. All right, and then the next part says choose a value outside of the shaded area of the number line. All right, so that's going to be anything this way. So I'm going to choose 10. And you can choose anything that is not in the shaded area. Substitute it into the original equality. So x is no longer x. X is 10. I have 10 plus 4 is less than 9, question mark. 10 plus 4 is 14. 14 is less than 9. No, that's not true. Does this value make the inequality true? No. So what does the shaded part of the inequality show? That shows, the shaded part shows the solution. That's a math word. Solution to the inequality. And what that means is any number, when you talk about the solution, any number in the shaded area of the graph is an answer to the inequality or to the problem. All right, so go ahead and take a minute and write that down. The shaded area shows all of the answers, and there's a lot. It's all those numbers to the left make that inequality true. Okay, so example 3 says solve an inequality by subtraction. A suitcase must weigh less than 50 pounds or an extra fee will be charged. Right, and we're familiar, those of us who have flown, we're familiar with a situation like this. Patrick's suitcase now weighs 38 pounds. How much weight could Patrick add to the suitcase without paying the extra fee? Okay, and we're going to do kind of a little graphic organizer. So the current weight is 38 pounds plus the extra weight that we don't know. I'm going to use W for my variable. Must be less than 50. All right, then it says solve the inequality using the algebraic process. So I have 38 plus W is less than 50. Subtract 38 from both sides. 50 minus 38 is 12. And that should be a less than sign. All right, so it says solve the inequality using the algebraic process. I did that right here. Graph the solution on a number line. So I have all right, so it's an open circle because it's less than, and it's all numbers to the left. So anything less than 12. So then it says, what does the solution tell you? That any weight less than 12 pounds Patrick does not have to pay a fee. All right, then it says, what if the souvenirs that Patrick buys on his trip weigh 14 pounds? Will he have to pay an extra fee if he packs them in his suitcase without taking anything out? 14 is greater than 12, so Patrick will have to pay a fee. If he takes out nothing. All right, so our last example says Allison solved the inequality n plus 3.4 is less than or equal to 5.8 as shown to the right. Identify the error that Allison made. Explain your reasoning. All right, so I like to work these first to see what answer that she should have gotten, and then I can go back and try to figure out what she did. So I'm actually going to do part B first. So I have n plus 3.4 is less than or equal to 5.8. I'm going to subtract 3.4 from both sides. N is less than or equal to 2.4. Okay, so this is what she should have gotten. And then let's see, so I've done part B. So let's go back up and see what she did. Alright, so she subtracted 3.4. Okay, that's what I did. Oh, then we get to the other side. And look what she did. She subtracted 3.4 from one side and negative 5.8 from the other side. So Allison did not subtract 3.4 from both sides. And there are a lot of ways to say that. That is not the only way to say it, but that's what makes sense to me. So I've done part B. How could Allison have determined that her answer is incorrect? One thing she could have done is substituted 0 in. For n, and saw that 0 is not a solution. All right, and part C has many correct answers, so if you have something different and you want to ask me, you can ask me in the morning. That is our lesson on how to solve an inequality by adding or subtracting. Again, it's very similar to equations. It's just now, instead of an equal sign, we have an inequality sign. If you still have questions, come see me in the morning.